So here what I defined, let P is equal to probability of getting some 10 on throwing of 2 dice, that a pair of dice thrown in any time. Probability of getting. So some 10 is 4 6 5 5 6 4, that is 3 by 36, that is 1 by 12. Since 4 6 5 5 6 4 are favorable cases to some 10, and total cases n of s is equal to 6 square in a pair of dice thrown, implies q is equal to 1 minus p is equal to 11 by 12. N is equal to how many times it is playing? 3. Let random variable capital X is equal to number of times getting some 10. So how many times he has thrown? 3 times of pair of dice. So in the first time you will get some 10, in the second time you may get 10, in the third time you may get some 10. So 3 times maximum, or no time is getting some 10. That means x value is 0. Out of 3 times of throwing 2 dice and giving some 10, you may get only 1 time getting some 10. You may get only 2 times getting some 10. You may get all times getting some 10. So x value is 0, 1, 2, 3. The last value n. Okay. That means x is follows binomial distribution with n comma p. N is 3, p is equal to 1 by 12. X is a binomial distribution. Therefore, p of x is equal to x. Its probability density probability mass function is ncx p power x q power n minus x. That is tens. (3cx) p is 1 by 12 11 by 12 q raised to n minus x. Now what is the question requires? What is the probability that the 10 sum of the numbers on the 2 will shows exactly once? Therefore p of that sum 10 will show exactly once. That is getting some 10 exactly 1 time. That is the meaning. So this is according to random variable p of x is equal to 1. That means put x is equal to 1 there. 3c1 1 by 12 whole power 1 and 11 by 12 whole power 3 minus 1 2. So this simplifies to 1728, and somewhere you write exactly means is equal to mathematics symbols I am giving. At least means greater than or equal to, converting into like this mathematical inequalities and equalities. At least, at most means less than or equal to. Please remember, while converting the given sentences after defining the random variable into that mathematical inequalities. 2005, another example. A lot has 10% defective items, full stop. 10 items are chosen randomly from this lot, full stop. The probability that exactly 2 of the chosen items are defective is answer 0.1937. Just hint, P is equal to probability of getting defective 10%, that is 0.1. Q is equal to 0.9. So N is equal to 10 items. X you define, then finally we require P of X is equal to 2. Okay, use binomial distribution as above and define X is equal to, this is our random variable, number of defective items. That means 0, 1, because 10 items are there. So on 10 last value is N. Just write this in, then you require according to the sentence, after defining that X, P of X is equal to 2, substitute here. Answer is 0.1937. Similarly, (2010), this is given, a fair coin is tossed independently 4 times. The probability of the event the number of times heads show up is more than the number of times tails up, comma, is. Answer for this 5/16. Hint, P is equal to probability of getting head in any time. Q is equal to 1/2. N is equal to 4 times. Let random variable X is equal to number of times getting head. So 0, 1, 2, 3, 4. then we require P of number of heads shown up more than tails means 3 heads, 1 tail, 4 tails, 4 heads, like that. X greater than or equal to 3. That means P of 3 plus P of 4. This is the answer. Just write the hints. Later you check. Same binomial distribution 2012 is given. In an experiment, positive and negative values are equally likely to occur. This is the question. One of you asked that, equally likely. The probability of obtaining at most one negative value in 5 trials is. Answer is 3 by 16. Hint: P is equal to 1 by 2, Q is equal to 1 by 2. Okay. Number of in 5 trials, 5. X is equal to random variable X is equal to number of times. What he asked the question? Negative values or positive values, no problem. If you define P probabilities of success getting a negative value, then this value is 0, 1, 2, 3, 4, 5. This is our N. What we require? At most, that means X less than or equal to 1. That means P of 0 plus P of 1 using binomial distribution. Then I am going to Poisson distribution. Poisson distribution. It is a limiting case of binomial distribution as or under n tends to infinity, that is n is large. And P tends to 0, that is P is small. Full stop. A discrete random variable X takes on values 0, 1, 2, so on, large, 100 or 1000 or etc. is said to be Poisson random variable with parameter lambda greater than 0 if its probability mass function is given by p of x is equal to exponential minus lambda power x by x factorial for x is equal to 0, 1, 2, so on. Here lambda sometimes n into p, where p is the probability of success, n is the number of trials. Okay, and lambda is a positive constant. And denoted by this Poisson distribution, x follows p of lambda. If lambda is not given, then you look at the number of trials and p is the probability of success. Okay. For Poisson distribution, we have mean comma expectation of x is equal to the parameter itself, and variance comma v of x is equal to lambda, implies mean is equal to variance. Please by heart, mean variance along with probability mass function, exponential minus lambda power x by x factor. That is, n is going large, p is very small. That is, for example, probability is equal to 1%. That is 1 by 100. That is 0.01, very small quantity. In 100 times or 1000 times, that is, n is large. In such cases, Poisson distribution gives accurate answer. Okay, apply Poisson distribution. Number of printing mistakes in a book. Okay, telephone calls, number of telephone calls, and number of accidents in a month. Okay, or in a week. Okay. Examples I am going to do by heart, please. One problem in one branch, 2013 GATE question, 2 marks. 1% of the cars manufactured by a company are defective. Full stop. What is the probability up to 4 decimals that more than 2 cars are defective, comma, if 100 cars are produced. Solution. Let P is equal to probability of a car manufactured by a company is defective. So what is given? 1%. That is 0.01, very small. Okay. N is equal to how many cars produced? 100 cars produced. Implies lambda I have given N into P, that is 1. Okay. Here random variable capital X is equal to number of defective cars. In 100 cars, 100 are defective, okay, or 0 are defective, or 1 are defective, like that. So that means 0, 1, 2, so on, okay, which implies X follows Poisson distribution with parameter lambda, and what is its probability function? Exponential minus lambda, lambda power x by x factorial. And what is the question asked? Therefore, probability of more than 2 cars are defective. So convert into mathematics notation, P of x greater than 2. So x greater than 2 out of 100, that is 2 is far away from 100. In such cases, this can be written as 1 minus P of x less than or equal to. That is the point useful in the, previously I have given some properties, P of a less x greater than a, x less than a, using that only I wrote, because 2 is far away from 100. 100 is the last value. Okay. So this is 1 minus P of 0 plus P of 1 plus P of 2. That means in the above substitute e power minus lambda common, e power minus 1 into P of 0, lambda power 0, 1 power 0 by 0 factorial, lambda is equal to 1, x value 0, 1 power 1 by 1 factorial, 1 square by 2 factorial. 2 plus 1 by 2, that is 5 by 2, 1 minus 2.5 e power minus 1, this simplifies to 0.08. You calculate. So one more example I am going to do. I am giving you solve this equation. Second example, if x is a Poisson variate such that p of x is equal to 2 is equal to 45 times p of x is equal to 6 minus 3 times p of x is equal to 4, comma, find 1 p of x greater than or equal to 1, second one p of x less than 2. Hint, lambda value, okay, lambda value will be getting 2. P of x greater than or equal to 1, answer is 0.8647, and P of x less than 2 is 0.594. After using your P of x is equal to x using Poisson PDF. Okay. Normal distribution, continuous distribution. We say that a continuous random variable capital X is a normal random variable with parameters mu and sigma square if the probability density function is given by f of x is equal to 1 divided by sigma times square root 2 pi exponential minus x minus mu by 2 sigma square, x minus mu whole square, x values minus infinity less than x less than infinity. And denoted by this distribution denoted by x follows normally normal variable with mu comma sigma square. Mean comma expectation of x is equal to mu and variance comma v of x is equal to sigma square. The graph of this is x is equal to mu, this is minus infinity, this is infinity, normal PDF f of x, this is y axis and this is x axis. that is normal curve y is equal to f of x. See, a continuous random variable with parameters mu and sigma square is said to be normal random variable if its PDF is given by this one, the graph of this one. So normal curve is symmetrical about mean. Mu stands for mean, that is mean mu variance sigma square, and this distribution denoted by n of mu comma sigma square. So here every time we depend on mean sigma square, that means the integral value n of mu comma sigma square varies with mu and sigma square, and the integral values can be evaluated numerically. So it is more reasonable to convert this normal distribution into standard normal distribution with mean 0 variance 1, so that integration values are evaluated readily evaluated. That integral values are available in any textbook after the end of that probability chapter, normal distribution table, normal curve values. Once you reduce your normal distribution into standard normal distribution. What is standard normal distribution? A normal distribution with mean 0 and variance 1, standard deviation 1. Okay, like that. Because every time, suppose if we ask 1 less than x less than 10, so that means once we know mu and sigma square, this is nothing but integral 1 to 10 f of x dx. So integration is difficult to evaluate. So due to this, to overcome from this, we reduce this normal distribution into standard normal distributions, and then that standard normal values are available in the textbook, or they are readily evaluated. Okay, that is more comfortable also once we bring the normal problems into standard normal problems. Since n of mu comma sigma square varies with mu and sigma square, and the integral can only be evaluated numerically, it is analytically difficult. Okay, comma, it is more reasonable to reduce this distribution to another distribution called standard normal distribution, denoted by n of 0 comma 1, that is mean is equal to 0 comma variance is equal to 1. See, it is difficult to evaluate analytically whenever we require probability of 1 less than x less than 10, where x is a normal random variable with mean something and variance something. So to overcome from this, it is more reasonable to reduce this distribution to standard normal distribution with mean 0 and variance 1, that values numerically evaluated that are available in the textbook. Okay, once we reduce any problem, normal distribution problem, into standard with standard normal distribution, that means mean 0 variance 1. That standard normal distribution denoted by z variable, normal variable denoted by capital X, to avoid the confusion between original ordinary normal distribution and standard normal distribution. for which the shape and hence integral values remains constant. So now I am giving the procedure for converting any normal distribution into standard normal distribution. If we let z, a capital variable, x minus mu by sigma, then z follows n of 0 comma 1, that is standard normal random variable, and PDF of z is given by f of z is equal to 1 by root over 2 pi exponential minus z square by 2 minus infinity less than z less than infinity. Just in the above normal distribution, put mean mu is equal to 0, sigma square is equal to 1, and x minus mu by sigma, this is going to reduce it. In such a way it is reduced at z. Okay. Mean expectation of z is equal to 0, and variance v of z is equal to 1. Z is standard normal variate and x is normal variate. Now what is the procedure? Converting a normal variate to standard normal variate, original normal variate minus its mean divided by standard deviation, that is simplifies to a new normal variate denoted by z called as standard normal variate, for which shape and area, everything is shape, integral values, all these things. Now normal distribution is symmetrical about with mean mu. Once we reduce into standard normal distribution, it is symmetrical about mean 0. For this is plus infinity, minus infinity, and this is z is equal to 0, standard normal curve f of z. Okay. Properties. The curve is bell shaped and symmetrical about x is equal to mu, about the line x is equal to mu, that is z is equal to 0. Mean, median and mode are coincide. 3. As x increases rapidly, as x increases numerically, comma f of x decreases rapidly. Similarly, these points applicable for standard normal variate also, properties. Fourth one, the maximum probability occurs at the point x is equal to mu, comma, is given by f of x maximum is equal to 1 by sigma times root 2 pi, and the points of inflection of the curve are at x is equal to mu plus or minus sigma. X-axis is an asymptote to the curve. Sixth one, total area under the normal curve is unity, that is minus infinity infinity f of x dx equal to 1. Similarly in terms of z also. Mean median mode. So you know mean average. Median means positional average after arranging the given data into ascending or descending order. Okay, number of observations even, then there are two medians, n by 2 and n by 2 plus 1th term, and then take the average. If the number of observations is odd, then median is equal to middle value, that is n plus 1 by 2th term is median. Mode is the maximum frequency that of a quantity is of a quantity most often. If a quantity, if an item is most often, it is repeated maximum number of times, that value is called mode. So once we reduce a problem into standard normal distribution, if you get a step like this, or minus infinity less than z less than 0 is equal to 0.5, because the total area is 1, total probability, so which is symmetrical about midpoint 0. So this left part area is 0.5 and right part area is 0.5. Area means minus infinity to 0 or 0 to infinity, standard normal curve. Okay. Probability of minus a less than or equal to z less than or equal to, where z is standard normal variate, 2 into probability of 0 less than or equal to z less than or equal to a. Probability of z greater than or equal to a is equal to probability of z less than or equal to minus a, and probability of z greater than or equal to minus a is equal to probability of z less than or equal to a, where z is standard normal random variable. Okay. So So always you remember the problems convert into standard normal variate with mean 0 and variance 1. Then these points while doing the problems you may get. Okay. And remember the shaded path, that Z curve, all these things. Suppose in this curve, go to all of you, this point tells that Z is equal to some Z1, and this straight line tells that Z is equal to Z2. So in this, what I shaded, that is shaded part, shaded area, is integral Z1 to Z2 f of Z dz. That is P of Z1 less than capital Z less than Z2 is equal to. Once we change into standard normal variate with extreme, say, numbers small z1, small z2, go to your graph, plot that either depending on z values, you may get the graph like this, or this side, or half part this side, half part this side. Then this area we are going to find. So just I am going to do one problem. Example, (2012) 2 marks. The annual precipitation data of a city is normally distributed with mean and standard deviation SD as 1000 mm and 200 mm respectively. Full stop. The probability that the annual precipitation will be more than 1200 mm is dash, and given that hint, probability of 0 less than z less than 1 is equal to 0.3413. Options A less than 50%, B greater than 50%, C only 50%, and C is 75%, D 100%. So this is option A is less than 50%. Solution C. X, this is normal random variable. Okay, follows n of mean 1000 and 200 square. So this is mu, this is sigma square. Okay, here that is annual precipitation data of a city. Okay, now let what I define in Z, x minus mu by sigma. This is standard normal variate or random variable. That is x minus mean means 1000 by sigma. Standard deviation is 200 given. Okay, so what we require here, probability of x greater than 1200. Okay, so convert into Z means subtracting mu and then dividing by sigma. Each is converting into Z. X minus mu by sigma greater than 1200 minus mu by sigma. This is I denoted by Z. Greater than 1200 minus mu 1000, 200 by 200, 1. So what is this? 0.5 minus P of 0 less than Z less than 1. Why we got like this? See, this is infinity minus infinity, center value Z0. What we asked? 1. 1 is right side to Z is equal to 0, Z is equal to 1. So here this is the required data. Okay, that so Z greater than 1 is obtained from this right side path greater than 0 I have given in 0.5 subtracted from 0 to 1. So that means 0.5 is nothing but probability of 0 less than Z less than infinity. That from that value you subtract this empty path 0 to 1. Okay. So what is P of 0 less than Z less than 1 is given 3.413. So whatever it may be, this is 7 and 9 from 1 8, 9 from 4 5 and 4 from 3 0.1, which is less than 50%. What is 50%? 50 by 100, 1 by 2. Okay. So according to the option A. So this is the procedure, converting a normal random variable into Z and then go to your graph. Whatever the thing required, that is also convert into Z, subtracting mu by divided by sigma, then come to original complete Z variable, go to your graph, plot that. So 0 to infinity I have given. Okay, since P of 0 less than Z less than infinity is equal to how much? 0.5. So from 0.5 you subtract that 0 to 1 region, you will get greater than 1 region. So I hope that you all understood. Tomorrow we will discuss more number of questions in all the chapters what happened so far. Okay, doubts session tomorrow. All of you prepare what happened so far, all the 4 units, and I will do 1 or 2 problems on this distribution, 1 Poisson distribution. Okay, problem. And similarly in all other chapters also I will try to do one more important problem. Okay.